Users expect your apps to be easy and quick to use, and they surely do not want to be slowed down by having to re-enter some data every time they launch the app. Think about it. Would you like it if the browser on your phone didn't remember the last website you opened? I doubt it. That's why good apps persist their state to local storage. Sure, you can handle persistence in many ways. However, if you are using the Flutter Bloc library, going the hydrated block route is the best choice you can make. Hello, welcome to ResoCoder, where you are getting prepared for real app development by building better, faster, more stable apps. So subscribe and hit the bell if you want to grow your coding skills. In this tutorial, we are going to build a hydrated weather app, which will be actually an extension on the weather app which we have built in one previous tutorial. In that tutorial, you can learn about the Bloc library in depth. So definitely check that out if you are just starting out with Bloc. However, if you already know a little something about Bloc and you do not need to go through the basics again, you can just get the starter project from the written tutorial, which is available from the link in the video description. Because over there you can find all of the code written in this video, links to all the libraries, and overall go through this lesson at your own pace. What we will do in this tutorial is that we will expand on the, so to say, non-persistent weather app, so that it will be persistent at the end of this tutorial. Whenever we search for a city, Missouri, and search for it, it's gonna be presented to us with some fake generated temperature. And then usually what will happen once you close the app and then reopen it again, so let's find it over here somewhere. What would usually happen is that the state would be lost, right? But that's not the case with hydrated Bloc, because it's going to remember where we left off, and we are going to be again presented with Missouri and the temperature, the fake temperature that's present over there. With the starter project in place, let's go over to pubspec.yaml file, and currently there are only the following libraries: Flutter Bloc and Equatable. We want to add some more libraries to this, more precisely the hydrated Bloc, and then, because hydrated Bloc operates with JSON and we will need to convert things to and from JSON, therefore we are also going to add the JSON serializable package. Just so that I do not bore you to death with these packages, I will copy and paste them over here, and as always you can get this code from the link in the video description. The thing that's gonna be persisted is the state. And in this app, we already have weather state. Weather state can be either initial, loading, or loaded. And the weather loaded state is what's of interest to us, because this weather loaded state is the only one which actually contains some real state. And that's the weather object. And weather is just a simple model class. If we take a look at that, it just contains city name and the temperature. So we now have two options of how to persist this weather loaded state. Since hydrated Bloc operates with JSON, we need to have the toJSON and fromJSON methods somewhere in here present. The question is whether we should add these toJSON and fromJSON conversion methods directly to the weather loaded state, or if we should instead serialize only the data which is present in this state. In this case, that's the weather class. To that, I will say that data operations, including serialization, certainly belong to the model class, because after all, that's what model should be all about. It should be about storing the data and converting the data and somehow massaging the data so that it fits the app's needs. The state should not do really anything other with data than to just pass it around the app. All of the other work around data should happen inside the model. So that's why we're going to serialize only this weather model class. So currently it's only a simple class extending Equatable. We want to add a part directive because JSON serializable works with code generation, as do almost all of the other Dart packages which do something similar. So weather.g.dart will be the generated file's name. And then we want to mark this with the JSON serializable annotation. Import all of that JSON annotation. And then we're gonna do some JSON serializable specific setup. So every class which can be serialized with JSON serializable needs to have a factory. So weather.from JSON, which will accept a map containing string keys and dynamic values. And then it will just call something inside the generated file, which we are going to generate in just a bit. And that will be $$ weather from JSON, and pass in the JSON map. And then similar to from JSON, we also want to have toJSON, which will return a map of string dynamic. So toJSON, which will call similarly $$ weather to JSON, and pass in this instance of the weather class. Now we obviously need to run the code generation, so we are going to use everyone's favorite Flutter command, that is Flutter packages pub run build runner, and we can just say build because we do not need to repeatedly call this build process, but you can also do watch instead of build. So let's just build it once. And after some time, we have the generated file present right over here. We do not need to touch it. Now we need to make sure that these methods for serializing and deserializing the weather model are actually called and persisted to the local storage. So let's go over to weather block. And usually, as it is now, all of the blocks extend the block base class superclass. With hydrated block, we're going to extend the hydrated block class. So let's import it here, and we no longer need to import block because we import hydrated block after all. Now the Dart compiler complains that we have an error here. That is because we need to add two missing overrides, which are from JSON and toJSON. Let's just move these methods up so that we can see them more clearly here. We're gonna come to these methods in just a little while, but we first will fix their types here because for some reason the type dynamic is not present. So the map which is passed into from JSON will be map string dynamic. And similarly, the returned type from toJSON will be map string dynamic. Again, we're gonna come to these methods in just a bit. First, let's talk about how the state is actually restored. Of course, the restoration happens once the block is first created. This makes sense. You wouldn't want the block to restore its previous state in the middle of running the app. And the initial state of the block is determined, well, inside the initial state property. So we want to modify it. It no longer will be just a simple arrow function. We instead want it to be a regular, or not function, but property. It will have curly braces instead. This is because there will be a bit more code than just one instantiation of a class. Over here, we first want to return super.initialState. And only if this superclass's initial state is null, will we return weather initial. This superclass call for the initial state will make the superclass try to get the stored state from the storage, but we have to account for a possibility that there will be nothing stored inside the storage, no state will be present, and in such case we are going to return the default initial state, which will not show anything on the screen basically. If we take a look at the implementation of initial state, inside hydrated block, we can see that it calls from JSON and it decodes some JSON over here. So it's loaded from the storage. Actually, if we take a look at this initial state implementation of the hydrated block more closely, we can see that it calls the from JSON method. And from JSON is nothing else than the method which we have overridden in the weather block. But first, before implementing from JSON, this one, let's implement toJSON. First, check if the state is weather loaded, because only this state can be actually serialized. And in such case, we're going to return state. We want to access the weather object on that state. And we can call toJSON because weather is JSON serializable. But what are we going to do if the current state is not weather loaded? Because we cannot serialize weather loading or weather initial. Only this weather loaded state can be serialized. Well, the answer is that otherwise we're going to return null. Returning null from here will indicate to the hydrated block package that it should leave the stored state as it is. So if the user exits the app before a new weather could be loaded, he will be presented with the previous weather upon launching the app. So this way we do not need to worry if the state is gonna be some state which we cannot serialize, for example, weather loading. Now with deserialization, so from JSON, we already know that it's called from the initial state superclass property. From JSON is called from here. So because of the way we've set up our own overridden initial state property, we expect the initial state to be null whenever there is nothing stored in the storage. So for example, when the app is launched for the totally first time on a device, this super.initial state will be null because there is no stored state, right? In such case, we are going to return weather initial with this null coalescing operator. So this means that inside from JSON, we want to return null whenever something goes wrong. For example, when there is no data inside the storage or when the data is malformed and so on. So what we want to do is to just wrap this code inside try catch. So try catch, we're going to catch any exception. And in try, we're going to get the weather from the JSON, which is passed in. So let's store it inside final weather is equal to weather dot from JSON and pass in the JSON. And then we're going to return weather loaded and pass in the weather, of course, into the state. And inside catch, we simply want to return null. So for example, if this map string dynamic is null because there is no data stored, we're going to try to parse null from JSON here. So JSON serializable is gonna throw an exception, we're gonna catch it here and return null, which in turn will make the initial state to be emitted as the initial state of our weather block. The final step in persisting the block state is to set a special kind of a block delegate on the block supervisor. This will happen inside the main.dart. Of course, depending on your experience with Bloc, you may or may not understand what a block delegate and the block supervisor is. In essence, block supervisor is a singleton with which every single block communicates whenever there's a new event dispatched or when a new state is emitted. This is what we are interested in because we are interested in states as we are serializing them. And it also calls the block supervisor whenever an error happens. Actually, when we go over to the block definition, so let's open the definition, and we just scroll down somewhere, we're going to find a call to block supervisor. For example, this call inside dispatch calls the onEvent method on the block supervisor's delegate. Similarly, whenever there is a new state, an onTransition method is called on the block supervisor's delegate from within the block. Speaking of delegates, the delegate is actually where the actual work happens, because if we take a look at the block supervisor, it's a lean class. There's nothing in here. The interesting stuff is inside the block delegate, because this class has the onEvent, onTransition, and onError methods. And usually you would subclass this block delegate class yourself and do some logging or something similar inside these onEvent, onTransition, and onError methods. But hydrated block package comes with its own ready-made hydrated block delegate, which subclass is this one. And in there, whenever there is a transition, which means that a new state is emitted, it automatically tries to persist the state to the storage. So if we now close all of these files which I have opened and go to the main.dart file, we want to set the hydrated block delegate inside the main method. So we're going to make it into a regular curly brace method. And before calling run app, we're going to call block supervisor .delegate. We should import the block supervisor. It's probably not gonna get imported by itself. So we need to import block, the core block package. And we want to set this delegate to be equal to hydrated block delegate .build. And of course, we again need to import the hydrated block delegate, but this build call is actually asynchronous. It returns a future. So we need to make this main function, because it's outside the class. So this main function should be asynchronous as well. And we are gonna await whatever is returned from this build call. And if we take a look at the hydrated block delegate, surely we can see that it overrides the onTransition. So this means whenever a new state is emitted, this onTransition will run. And it tries to save the state of the block if the block in question is a hydrated block subclass. So it's saving the state to the storage. And the storage is just a simple file. You can also override this hydrated storage with your own implementation, but we are not going to get into that in this tutorial. But you can completely customize the hydrated block package to your liking. You could, for example, use something like the Sandbass package to store the data and also to encrypt it and all of that good stuff if you want to have some encryption with your hydrated blocks. All right, so now once we run the app, upon the first launch of the app, the state is of course whether initial, because this super.initial state is null. But then once we search for a city and wait for it, and then we do hot restart, which if you know something about Flutter, hot restart completely gets rid of the state as opposed to hot reload. So to hot restart, we can just hit this restart button here. Once we go back, we can see that the app is completely fine. It didn't lose its state. We are still showing London. If we change to Nashville and search for it again, and just for good measure, we are going to again hot restart. It's still in Nashville, so that's completely awesome. To go through this tutorial at your own pace once again, check out the written tutorial, which is available from the link in the video description. And if you do not want to miss more tutorials like this one, definitely subscribe to this channel and also join the notification squad by hitting the bell button to make sure you grow your Flutter coding skills, because here on ResoCoder, I am determined to provide you with the best app development tutorials and resources out there. If this video helped you to understand the hydrated block package, how to use it in your apps to persist your app state, Give this video a like and also share it with other developers who will surely benefit from it too. Leave a comment if you have any suggestions or questions. Follow me on Instagram. I go under the name ResoCoder everywhere, and if you follow me there, you're gonna know about what's cooking behind the scenes, which kind of tutorials you can expect, and see you in the next video.